All right, hi everyone. Today we're going to be going over our machine learning project that we worked on with National Indemnity over the last 8 months. To give a little background on the company we work with, National Indemnity is an insurance firm that specializes in commercial trucking companies. So moving forward, none of the work that we've done was with individual vehicles. It is exclusively with corporations and commercial trucks. So moving on to the stakeholders that were our primary contacts over the course of this project, we have Cody Oltman and Tim Oltekin. They were incredibly helpful, helping us get the project to where it is today, working with us up to 2 hours a week outside of normal schedules, making sure we had everything we need. So we are very grateful. Moving on to our faculty stakeholders, many of you who are in senior design are likely familiar with these faces. However, I'll give a brief introduction. Our project manager is Melanie Kugler-Wright, our tribe lead is Vinod Variam, and our coach is Mark Antonson. So moving on to our student team. My name is Neil Avery. I was the squad lead and development manager. Standing next to me is Juan Choi, one of our developers. And if you'd like to meet the rest of our team, our product manager is Nick Colleran, and our developers are Connor Wires, Garrett Snitchler, and David Jordan. So to give a brief background on the problem and opportunity we were faced with when presented this project, due to the increase in technology with insurance and telematics in general, many companies are using a telematics approach to ingest large amounts of data from their vehicles to be used as an incentive for to reduce their insurance premiums by identifying good and bad behaviors. And so dealing with these large amounts of data can be very difficult, especially using traditional methods. And so we were given the opportunity to build a machine learning model that is able to stream this data from APIs and ingest it to determine an accurate score that can be used to grade different vehicles. So I'll be passing it off to Juan to look over our product solution.
Okay, thank you, Neil.
Sure.
All right, so before I dive straight into the product solution, I do want to mention that I did write a full page of script, but I don't think I'm going to get to reading all of them, and you probably don't want to hear that, so I'm just kind of not going to bother. But yeah, so as Neil had mentioned previously, the scope of this project involved around machine learning. And for those of you who are not quite familiar with the capabilities of what machine learning does, is machine learning is something, it's an algorithm that can take a mass amount of data where humans cannot take. So in our case, with the telematics data being provided from National Indemnity, we were dealing with 3,000 vehicles, which each vehicles were producing about 4 data points per second. So that would make it 12,000 data points per second, and humans would not be able to process that at once. So that's why we decided to, and that's why the scope of this project was involved around the machine learning model. Excuse me, and that's, yeah, so what we did here was we were able to take in all of those telematics data, feed it into a chart called data frame. We did a lot of data manipulations with it to figure out certain events like a driver's harsh braking, harsh acceleration, harsh deceleration, or even some cases where if the drivers would park at a wrong location, or even some counties that are known to be more prone to crimes or natural disasters. So with all those data and manipulated data put into one data frame, we fed it into the machine learning model. And the machine learning model that we chose was called XGBoost model, which is a variant of the gradient boosting machine learning model. And the key reason behind why we did this was because machine learnings are kind of like a child per se. You know, you're trying to teach a pattern to a child by feeding in the data, so the child can look into the data and figure out if they did things right or wrong. However, for them to figure out what they did right or wrong, they need those things called correct answers, and it's actually called labeled data. So in our case, we weren't quite provided with the proper labeled data. And considering that none of the senior design team members are capable or qualified to come up with the correct insurance rate or like a driver's habit score based off of the data we were given. So we actually wanted to focus on allowing each members from NICO or from National Indemnity to be able to customize the model and then train it based on their preference. So later when that's done, so the data scientists of National Indemnity can take a look at it. They're like, okay, so this graph curve looks good, this looks all right, so we want to change certain things, we want to put more weights on certain events, because we think drivers' habits are more important than the actual make and year of the vehicle. So to allow that, we were able to create a standalone dashboard, which again allows the users to simply go in and goes through drop-down menus to change parameters and weights of each event. And with those adjusted parameters and weights, the model will be trained, and then it'll output the statistical data, including the graphs associated with it, again for the ease of National Indemnity members. And then for last but most important, it allows simplicity of each underwriters to simply go into the software and type in the vehicle ID, like VIN, except for with National Indemnity, they call it the vehicle ID. They can just simply type that in, and that should return some sort of a risk index score they can, the underwriters can refer to and make their decisions on when they're assigning insurance rates. Moving on to the next slide. Yeah, so this project was a huge one, and it probably was for a lot of any other senior design teams. But considering that this project was something that none of our team members had any experience with, because it's a relatively new field of AI, I feel like this project had brought a lot of value to National Indemnity and to our team. So the main idea, again, behind was to be able to create a machine learning model that would some sort of do some sort of mimics on human behavior, but instead of not just like human behavior, but do a better job than human. So with the provided data and with assuming that it would be trained properly, then it would be able to simply provide each individual's the right, in theory, the right risk index without making any mistakes. And we also, during the project, we also focused on core software, core methods, what do you call that?
Behaviors.
Behaviors, yes, which are such as like modularity and extensibility, readability, extensibility, modularity. So we wanted to make sure that each individual developers that would come in either in the future senior design team or from National Indemnity to simply be able to make improvements and modifications to the model. In terms about the highlights for the team, this project was special because again, the whole theme of the senior design is for the students to be able to work with companies outside the university, and they would be able to get some real world experience. For us, it was a little more challenging because we were dealing with a company with strict security policies, which means none of the data could be leaked and it cannot be downloaded to our personal computers. So we actually had to use National Indemnity's computer ourselves. So we learned how to deal with administrative pushes, working with IT departments, and those things are going to be something that we're going to be going through and running into a lot once we actually join the industry. So yeah, so far that is all we have prepared for today, and I think right now would be a great time for questions.